In this MCQ, we have one GP where the value of R is 1 by 3 and we have S4 and we have to find the value of A. So, we should use formula of S4. Here, your R is less than 1. So, we can say your S4 must be A into 1 minus R raised to 4 upon 1 minus R. Now, let's substitute the value. Your S4 is 80 by 27. We have to find the value of A. And in numerator, we have 1 minus R, or we can say 1 upon 3 raised to 4. And in denominator, we'll get 1 minus 1 by 3. In further simplification, we can say in numerator, we have to take LCM of 3 raised to 4. So we will get 3 raised to 4 minus 1 upon 3 raised to 4. And in denominator, if we take LCM of 3, we will get 3 by 2. Now, we know that 27 is nothing but 3 raised to 3. So 3 raised to 3, 3 raised to 4 and 3 will be cancelled out. And we will get 80 is equal to A into 3 raised to 4 minus 1, or we can say 81 minus 1 will become 80 divided by 2. Here, your 80 will be cancelled out, and if we move your 2 on the left side, we will get A is equal to 2, which is given in option C. Ta-da! In this MCQ, it is given that the first term of GP is 3 and the common ratio is given as 2. And we have to find sum of first 5 to 10 terms. Or we can say we have to find S10 minus S5. Here we have one shortcut that if we have to find S raised to n minus S raised to m, then we can use A into R raised to n minus R raised to m upon R minus 1. Okay. Now we know that we have to find S10 minus S5. So, if we substitute the value of A, it is 3. We'll get R raised to 10 minus R raised to 5 upon R minus 1. Now, in further simplification, from numerator, we can take R raised to 5 common, where the value of R is 2. So, within the bracket, we have 2 raised to 5 minus 1 upon 2 minus 1. So, we will get 3 into 2 raised to 5, which is 32, and 2 raised to 5 minus 1 is nothing but 31. So, your final answer is 2976, which is given in option A. Ta-da! In this question, it is given that your third term of GP is 3. So we can say AR raised to 2 must be 3. Then we have to find product of first 5 terms, where your first term is A, second term will be AR, third term will be AR square, fourth term will be AR cube, and fifth term will be AR raised to. So here we have 5 times A. So we'll get A raised to 5 and R raised to 1 plus 2 plus 3 plus 4. So here we'll get A raised to 5 and R raised to 10. So we can say we have whole raised to 5 of A R square, and we know the value of A R square. It is given as 3. So your final answer is 3 raised to 5, which is given in option A. Ta-da! Now, here we have one simple question. It is directly given that A equal to 16, T5 is 81 and we have to find the value of r. So we are going to use the formula of T5, which is simply ar raised to 5 minus 1, or we can say 4. Now let's substitute the values. Your T5 is given as 81. Your first term is 16 and we have r raised to 4. So we can say r raised to 4 is nothing but 81, or we can say 3 raised to 4 upon 16, or we can say 2 raised to 4, which will give us r is equal to 3 by 2, which is given in option B. Ta-da! Now in this question we have one GP, 1 by 3, 1 by 6, 1 by 12 up to so on. And it is given that your Tn is 1 upon 1536 and we have to find the value of n. So from the GP we can say your first term is 1 by 3 and the common ratio of second term upon first term is given as 1 by 2. So here we are going to use the formula of Tn, which is a into r raised to n minus 1. Now let's substitute the value. Your Tn is 1 upon 1536. Your a is 1 by 3 into 1 by 2 raised to n minus 1. Now we know that 3 and 1536 will cancel out. We will get 1 upon 512, which is nothing but 2 raised to 9. So we'll get 1 upon 2 raised to n minus 1 is equal to 2 raised to 9. By comparing power of n, we can say we will get n minus 1 is equal to 9, or we can say your n must be 10, which is given in option D. Ta-da! In this question, it is given that your ABC are in GP and we have a raised to 1 by x is equal to b raised to 1 by y is equal to c raised to 1 by z. Then we have to find x, y, z are in which progression. So let's take log on each side. So we will get log a raised to 1 by x is equal to log b raised to 1 by y is equal to log c raised to 1 by z. Now we know the property of log. We can move the power within the multiplication of log. Let's assume that it is equal to k. Now by comparing first and last term, we can get log a is equal to x into k. Similarly, from second term, we will get log b is equal to yk. And from third term, we will get log c is equal to z into k. Now, let's use the given condition where ABC are in GP. So we can say b square must be equal to a into c. So if we take log on both sides, we will get 2 times log b is equal to log a plus log c. Now we know that the value of log b is yk, log a is xk, and log c is zk. So we can take k common and it will be cancel out from both sides. So we will get 2y is equal to x plus z, which suggests that your x, y, z are in AP, which is given in option A. Ta-da! Now here we have one interesting question. It is given that your ABC is in GP. So we can say B square is equal to AC will become your first equation. Now arithmetical mean of A and B is x. So we can say your x must be a plus b by 2. And arithmetical mean of b and c is y. So y must be b plus c by 2. Then we have to check following options. Now as you can see in all options, we have to find value of 1 upon x plus 1 upon y. So let's try to find this thing. Your 1 upon x is nothing but 2 upon a plus b, and your 1 upon y will be 2 upon b plus c. Now here we can take 2 common and take LCM. So we'll get b plus c plus a plus b upon a plus b into b plus c. So in numerator we will get a plus, we have b 2 times, so 2b and c. In denominator, if we open the bracket, we have to multiply a with b, will give us ab, then a into c will give us ac, then multiply b with b will give us b square, and b. Now we already know that your b square is equal to ac, so instead of ac we can write down b square. So we can say your numerator will be as it is, and in denominator we'll get ab, b square plus b square, or we can say 2b square plus bc. Now we have b as a common term. So again, for further simplification, your numerator will be as it is, and in denominator we can take b common. So remaining terms will be a plus 2b plus c. So here a plus 2b plus c will be cancelled out, and we will get 1 upon b, or we can say 1 upon x plus 1 upon y will be equal to 2 upon b, which is given in option D. Here we have one interesting question. Your Sn is 1 plus 1 by 2 plus 1 by 4 up to 1 upon 2 raised to n minus 1. So you can say in this question we have GP, where your first term is 1 and the common ratio between second term upon first term is 1 by 2, which is less than 1. So we have to check following options. Now when your R is less than 1, we can say sum of infinity terms is equal to A upon 1 minus R. So if we substitute the values, we will get 1 upon 1 minus half will give us 2. So if sum of infinity terms will be 2, then we can say sum of 100 terms must be less than 2, which is also less than 100. So we can say your option A is the correct option. Ta-da!